Good morning, I'm Lee Kon Pang. Today I'm going to present on the introduction of this project which is the antenna tower design. We designed the antenna tower by using the AutoCAD software. The AutoCAD is a software that allows for 2D and 3D drawing, drafting, and engineering. AutoCAD can be used to sketch record data such as tolerance, prototype building materials, and analyze drawings without generating prototypes. AutoCAD software caters to specific work functions and sectors, where AutoCAD is the most widely utilized computer-aided design CAD software and has the highest job market demand. We're using the AutoCAD software to create the 3D model for the antenna tower. Creating a 3D model requires a difficult process that involves idealizing a real structure and turning it into a virtual one. The initial points are the loads, supports, geometry, and anticipated displacements and deformations. To conduct structural and model analysis, a virtual 3D model is necessary. Has rapidly expanding communication network has resulted in the construction of several communication towers nationwide, where all the communication mediums, including telephones, radios, internet, and television, require daily monitoring and installation of antenna tower to function properly. The three most common types of communication towers are the self-supporting towers, monopole towers, and the guide mesh tower. The antenna tower we design is the self-supporting tower. These types of towers differ based on its structural actions, geometry of cross-section, material of section, and displacement of tower itself. Tower geometry is generally known to be part of factors that contributing to finding its optimum design. That's all. Thank you.
My name is Nabizuki bin Farazi. I will present product background. Antenna towers are crucial for modern communication, enabling a seamless connectivity and information transmission. Originating in the early 20th century for maritime and military use, they evolved to support television, cellular, and data networks. These towers, built with reinforced concrete foundations and steel or aluminum structures, support various antennas. They are vital for telecommunications, broadcasting, emergency services, military communication, and rural internet provision. Technological advancement have made antenna towers more efficient and sustainable with smart monitoring and green energy solutions. The growing demand for wireless communication and 5G networks drives their market growth, highlighting their importance in the global communication ecosystems. As technology advances, antenna towers will continue to evolve, meeting connectivity and sustainability challenges.
Objectives and scope. The primary objective of this project is to design an antenna tower, including detailed foundation plans and to perform a comprehensive analysis of the structure. The design process will consider the following basic parameters: the base width of the tower, the height of the tower, and the overall configuration of the tower. First is design a detailed antenna tower by using AutoCAD that ensures accurate representation of all structural elements. And second, to optimize the design to meet safety and regulatory requirements while being as economical, as material efficient, and as simple to construct as possible. To fulfill the objectives stated, the scopes are as follows. First, design the foundation based on the necessary structural, load and technical data to create comprehensive foundation plans with dimensions, reinforcement, and material specification by using AutoCAD. Secondly, to create precise and understandable documentation that can be used by construction teams.
This methodology shows the applications of AutoCAD in 3D modeling. Many commands were used when drawing different segments of the antenna tower. For example, rectangle and extrude command for base drawing, box, move and align command for first two cubic layers, line, array, trim and extend command for trusses design, pyramid and sphere command for lower top and upper top section, move and union command for all parts positioning, dimensions and dim linear for all measurements. This is our antenna design mind map. All drawings and dimensions are scaled to 1 to 100 to the real object. For the tower body, there are 7 layers in total. First two layers are made up of two 3-meter length cubic, third layer 3-meter length top and 4-meter length square base. Same measurements are applied to every layer by adding 1 meter in length each until the lowest part, which is 8 meter in length. We apply truss structure design. Cross trusses are added in each layer and face to provide stability of tower. For every column, we use 0.2 meter thickness. For the tower base, it is made up of 8.4 meter of length square base and 1 meter in height. For the upper top, middle top part is made up of a square base, 5-meter height pyramid, and the upper top part is made up of 0.8 meter radius sphere, which acts as a FM broadcast antenna radome. For the lower top, lower layer of the top part is designed 1 meter square top and 3 meter square base, and 0.2 meter also thickness for every column. And the image below shows a full 3D view of our antenna tower. This slide shows our AutoCAD drawing and dimensions. The first picture shows the front layout dimension of our antenna tower. The second picture shows our top layout dimension, and the third picture shows the 3D layout of our final product.
Product design advantage and practically. First, increase productivity, improve signal strength and coverage. Well-built towers guarantee that telecommunication equipment operates at peak efficiency. Next is dependability and safety. Structural integrity. A sturdy design lowers chance of collapse or damage by guaranteeing that tower can withstand external forces like wind, earthquake, and other loads. Next is expense effectiveness. Careful planning and can minimize labor requirements, streamline the construction process, cut project expenses all around. Next is aesthetic appeal. In urban or scenic area, modern design can have a greater visual impact and blend in better with the surrounding. And lastly is flexibility and scalability. A well thought out tower is an adaptable long-term investment since it can handle upcoming technical advancement or expansion. Upgrades and repairs can be made easier with the use of modular components in design. Practical of product design in telecommunication towers. First is truth planning and illustration. Using AutoCAD for detailed design and modeling enables accurate planning and visualization of the tower structure prior to the start of constructions, guaranteeing that all components work together harmoniously. 3D modeling facilitates better decision making by adding in the understanding of potential problems and the spatial arrangement. Next is project adherence. Accurate project timelines made possible by detailed design documents aid in keeping construction on schedule. And lastly is implementation on sites. By providing comprehensive construction drawings and guidelines, construction teams can minimize errors and network and building the tower more accurately.
Next, for conclusion, this AutoCAD project aimed to design an antenna tower with detailed foundation plans and conduct a structural analysis. Objectives included accurate representation of structural elements, optimizing for safety and compliance, and ensuring material efficiency. The project enhanced productivity, safety, effectiveness, and scalability. AutoCAD facilitated accurate planning, visualization, and documentation, improving signal strength, minimizing errors, and adhering to standards, resulting in efficient and visually appealing tower construction.